Okay, so chapter 2. Chapter 2 is basically your right triangle trigonometry. It's when you learn how to find all missing information about a right triangle by using SOHCAHTOA. Hopefully you know what this means. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. So all you had to know is 2 facts. And if you had 2 facts, you could solve everything else having to do with the triangle. Okay? The chapter began with the idea of what a reference angle is. Let me try that again. What a reference angle is. And a reference angle is a positive acute angle, right? A positive acute angle. And it was basically how you learned that once you knew that sine of 30 was 1/2, you could find a cousin in each one of the other quadrants. So you had an angle whose reference angle was 30 degrees in quadrant 2, and in quadrant 3, and in quadrant 4. You also learned about the idea of coterminal angles. Coterminal angles are angles that share the same terminal side. And how do you find coterminal angles? You add and subtract 360 degrees, otherwise known as 2 pi. At some point, either in this chapter or later on in chapter 3, you learned basically how to go from degrees to radians, and conversely from radians to degrees. And don't be surprised if you see a lot of radians on your final exam, because apparently going into calculus next year, most everything they do is in radians and not in degrees. So it's a very good idea to practice in radians rather than degrees, but you know you can always convert it yourself, right? If you had something in degrees and you wanted to change it to radians, you would multiply by pi over 180. And conversely, if you had something in radians and you had the desire to change it to degrees, you would multiply by 180 over pi. So chapter 3, reference, coterminal, degrees to radians, radians to degrees, being able to solve for any missing sides and angles. So solve for missing angles or sides. The only tricky thing in chapter 2 sometimes had to do with when they talked about an angle of elevation or an angle of depression. And it's important that you know what that looks like. So anytime you are doing an angle of elevation or depression, the angle is created by what? The horizon and your line of sight. So if you are up here in a tree looking down at a squirrel and they talk about an angle of depression because you're looking down at the squirrel, okay, that's your line of sight. But where's the horizon? Up here. That's the angle. It is never this angle right here. That's the mistake some of you've made in the past. So anytime they talk about an angle of elevation or depression, keep in mind that it's created by the horizon, meaning a horizontal line where you are, okay, and your line of sight. And so at that point, when you get done with this, this is the angle you're going to use for your triangle right here. And then you're going to use a fact from geometry that you have 2 parallel lines cut by a transversal, making alternate interior angles congruent. But you never have an angle here. When they talk about an angle of elevation or depression, it is never this angle. It always ends up being the angle down here. Okay? The other thing to remember about Chapter 2 is basically this is when you began learning and becoming very, very personally involved with the unit circle. And while you're at it, the unit circle obviously was created by the special right triangles. That's where you learned how to calculate your unit circle, was basically by remembering the relationship between those two special right triangles, and that's where all your information came from for your unit circle. Okay? So those are the most important topics about Chapter 2. Okay, so let's say that you are sitting on a rooftop, and the angle of elevation looking up at a star is 27 degrees. And let's say you know that someone told you that it was 100,000 miles from your rooftop to the star, okay? And you're wondering how high in the sky is the star, okay? You basically say, relative to this angle right here, this is my side that is opposite. This is my side that is hypotenuse, so I'm going to use sine. And so I say sine of 27 degrees equals x over 100,000. And I multiply both sides by 100,000. And whatever I get is my answer. Okay, so if it's sine of 30 degrees equals x over 100,000, what's sine of 30? 1/2. So 1/2 times 100,000, and so the answer would be that the star is 50,000 miles high in the sky.